All right, so we're going to build the smallest application we can build that interacts with the XNA framework and captures sound. Let's take a quick look at the solution. First, we added the XNA framework and XNA framework gamer services library references so that we can access the XNA framework. Then we added a couple of images from the SDK icon library, one of a microphone and one of a square or a stop button, so that we can have our button at the bottom of the screen in the application bar toggle back and forth between record and stop. And then finally, we built some code. So in our code, we have system.windows.threading because we need to create a dispatch timer to create a periodic callback in order to drive the XNA framework. And then we have the two XNA framework usings so that we can get to the basic framework and we can also get to the audio, which is where the microphone code is located. In terms of instance variables for our main page here, we have a microphone object, which is how we're going to ask the system to start feeding us data. We assign it to the microphone default property. Currently, no Windows Phone devices have more than one microphone, but in the future, it might be possible to differentiate between the hardware microphone on the device and a microphone on a headset. Then we have a buffer in which we're going to put the samples returned to us by the XNA framework, and then a memory stream where we're going to write the buffers out. As each buffer comes in, we write it out to this stream so that when we're done, we could then save that stream to a file, which we'll be doing in a future chapter. And then finally, we have a Boolean here in recording mode, which we use to determine what we should do when someone taps the button on the application bar. If we're not in recording mode, we start recording. If we are in recording mode, we stop. As I mentioned, in order to use code from the XNA framework, we need to essentially poll the XNA framework by calling this method frameworkdispatcher.update. And this code here in the middle of the screen right now simply creates a timer that fires off every 15 milliseconds and calls framework dispatcher update so that we can get frequent updates of data from the microphone. And finally, in order to start, we need to fire it off just once in order to be able to get things going. When we're ready to figure out how big of a buffer of data we want, we tell the microphone how much data we want per callback. In this case, we're saying a half a second worth of data, which is good for our first application because we can see the data coming in at a slow enough rate that we can manage. In one of the later recordings in this chapter, we're actually going to cut that way down so that we can actually display some visual feedback, which we need to do a lot more quickly than every half a second. And finally, we tell the microphone, here's your buffer ready handler. Here's our event handler for when microphone data is ready, call us back there. We also have a main page loaded event handler that sets one of the text boxes on our user interface to say tap record to begin when the page is loaded. Once we start recording, the microphone code in the XNA framework will fire its buffer ready event, which we attach to this microphone buffer ready method, and give us a buffer full of data each time. So we write out how much data we got, we write that stream to the buffer, and then we figure out what position we are within that recording stream and set a text block on our screen so that we can show the user 1 second, 2 seconds, 3 seconds of recording. And finally, we have the code that handles our record button. As we mentioned before, if we're in recording mode, we stop, change the text for the button back to record, set the image for the button back to the microphone, and set the text block to say recording complete. And of course, we set in recording mode false. If we're not recording, we create a new memory stream. We go allocate the buffer by asking the microphone to give us its sample size in bytes based on the duration that we told it. So we said to it, we want to be called every half a second. It's then going to compute how many bytes that is so we can allocate our buffer. And we change the text of the button to stop, and we change the image to the appbar.stop.rest PNG file. And finally, we call microphone start, which starts the process of the microphone calling us back, giving us buffers full of data, and we set in recording mode to true. So let's give this a try. So we have a single portrait page template that we started with. We set the name to record and play. We have a text box here where we're going to put the time, and we have our app bar down here with our recording button. So we touch the recording button, and we're now recording. You can see the time is updating, and you can also see our debug output saying we've received 16,000 bytes and another 16,000 bytes and another 16,000 bytes. And you can see, if you're looking at a large enough screen, that the size of the scroll bar thumb here is getting smaller and smaller because this is continuing on as we get more and more of these lines in the debug output. So now we know We've got the basic recording mechanism going. We're getting data back from the recording. And let's move on to the next part where we'll actually take a look at that data and provide some visual feedback of the data actually coming in.